All right, so here's 3.1 part A. Part A, what we're dealing with here is we're really looking at trying to solve things algebraically, and then they're going to compare that with a graph. Eventually, I think we'll get away from the graphs, but we need to know why are we solving things and what is the solution to them. So here we begin with question number 1. I'm going to pump this up a little bit so we can see it. It says, if you were given the quadratic function x squared equals 9, how would you solve? Well, most of us want to solve it verbally, and we want to say x is equal to 3, which it is, because 3 times 3 is 9. But you have to think, is there also another number times itself that's equal to 9? And the answer to that is x is equal to negative 3. So x is equal to plus or minus 3, essentially is what we're saying. So how we solve this algebraically is what we're going to do is we're going to take the square root of both sides. The square root of x squared, you must think about it, the same thing times itself. That's essentially what x squared says. If I take the square root of it, it takes 2 to make 1, or 2 to pull 1 out. So this becomes x equals, and in front of a radical we put plus or minus, no radical symbol, the radical disappears, and we get 3. So there's your answer there. Question number 2 says graph the function. Well, I'm going to identify A, H, and K. A is 1. H is the parentheses. Remember, A equals, excuse me, not A equals, Y equals A, X minus H squared plus K, the formula. Okay, we have shifting, no parentheses, it's 0. No value on the end, so K is 0. So my vertex is 0, 0. I'm going to move right 1 up 1. Right 2 up 4, right 3 up 9. Mirror that on the other side, and there's my parabola. For what values of x does f of x equal 9? This is where you have to pay attention. It's not saying input values equals 9, it's saying output values. Remember, we would see a table and we would say, what is f of negative 2? And we look at the table, we look where x is negative 2 and find the output. Yeah, that's not this. This is saying what values of x is my output? 9. Output is a y value. So I'm going to go up to 9 right here. And where are my outputs? 9. My outputs are 9 right here, which is negative 3, and right here, which is positive 3, which matches that. So how did we find those values? We looked at the graph. Okay. How do they compare to the solutions of the equation? They're the same. Okay, they're the same. I'm doing this pretty quick because this is a video. So number 3, we want to solve this algebraically. It looks very similar to AH and K, but it's not, because this is equals 4. So first thing I'm going to do is I'm going to go ahead and I'm going to rewrite the equation. So x minus 1 squared equals 4. You would agree if I could get rid of the exponent, I could add 1 to both sides and I'd solve, right? Well, I'm given this. So I want to do something to get to a next statement. What am I going to do? I'm going to take the square root of both sides. So my next statement is going to be x minus 1 equals the square root of 4, which is plus or minus 2. So what did I do? I took the square root, right, of both sides. That's important because when you solve problems, you got to do the same thing to both sides, right? Well, at this point, now what I'm going to do is I'm going to add 1. Okay? So x is going to be equal to 1 plus or minus 2. And what did I do? I add 1 both sides. Again, there's justification for doing what I did. So 1 plus 2 is 3, so x equals 3, or 1 minus 2 is negative 1, so 3 is equal to 2 or negative 1. Now go back and look at your, well, no, sorry, we can't go back, different. We will here in a second. So now we solved this, right? So I'm going to predict at 3, 1, 2, 3, and 4, 1, 2, 3, 4, because 3 and 4, or negative 1 and 4, so negative 1 and 4, those points are going to be on my graph. At 4, my graph is going to pass through those 2 points. So I want to graph this. Well, A, H, K. A is 1, H is also positive 1, K is 0. So at 1 and 0, write 1 up 1, write 2 up 4. Hey, it is. Write 3 up 9. Mirror those on the other side. My y-intercept is 0 and 1, which I don't see that anywhere. You're not going to, because it's not in the correct form. And there's your graph. But I said at 4, 3 and negative 1, those points. All right? Number 4, this one was kind of tough. How did we handle this? It says at f of 1. So for an output of 1, what input? Well, the first thing I did here in this one, and this was tough. This was a really tough problem yesterday. X squared minus 6x minus 7 equals 1. The first thing I did was I added 1 to both sides. All right? So by adding 1, so I get minus x squared minus 6 plus 8 equals 0. I'm setting equal to 0. Okay? I can't solve it algebraically the same way I solved the previous one. I've got to do this differently because I can't use inverse operations to solve this one. This was what makes this one so complicated. What I'm going to do now is I'm going to divide by negative 1 because I don't like negatives. So negative 1, x squared plus 6x plus 8 equals 0. What did I do? I divided by negative 1. I took out a factor of negative 1. So negative 1, now that I factored negative 1, I'm going to go ahead and I'm going to factor this right here. So factors of 8, 1 and 8, 2 and 4 that give me 6. That's going to be 4 plus 2. So my factors here are going to be x plus 4 and x plus 2. Okay, so I factored. But how do I solve? Because all of this is all about solving. I want to solve this. Well, we kind of know how, but I didn't tell you were solving. The book didn't tell us we were solving. To this point, all I've done is factor. To solve, we set equal to 0 and solve. So right here, x plus 4 equals 0, x plus 2 equals 0, and minus 1 equals 0. Now why did I set minus 1 equals 0? Because you set every factor equal to 0. Negative 1 is a factor. I took it out. If I didn't take negative 1 out, I'd have minus x minus 4. But I took negative 1 out. This is nothing. It ends up being nothing. How do I get x by itself? I minus 4 from both sides. So minus 4 minus 4, minus 2 minus 2. Therefore, x is equal to minus 4 or minus 2. There, I solved. Your x-intercepts, because I set it equal to 0, not 4. The previous one was equal to, it wanted a different output value. Here, f of x is equal to 1. Well, I still haven't found that out yet. What I did was find my x-intercepts. So 1, 2, negative 4. My axis of symmetry is in between that. Now what I said in the previous one is I'm going to have 2 values where my output is 1, possibly. Right? And I would see that in a table. Well, what am I doing here? I'm solving it the only way I know how. I'm finding the x-intercepts. Now that I found the x-intercepts, I found the x value of the vertex, which is negative 3. So using that, I can plug it back into either factored form or this standard form, and I can find out where that vertex is. And remember, I want to find out my solution at positive 1. Where does my graph hit this line? Does it hit once, twice? What does it hit? Well, negative 1 times negative 3 plus 4, because I need to find the output, and minus 3 plus 2 is going to give me negative 1 times positive 1 times negative 1. That's a whole lot of 1s, which is going to be equal to 1. Negative times a positive is negative. Negative times negative is positive, so plus 1. So negative 3 plus 1. Hey, I only have one solution, and that's at negative 3 and 1. And that was a lot. All right. Number 5. If you're given the function f of x equals minus x, or x minus 4 times x plus 3, and asked to find the x-intercepts, what quadratic function would you be solving? You would be solving 0 times x minus 4 times x plus 3. Why? Because you're finding x-intercepts. And anytime we have an x-intercept, remember, anytime we have an x-intercept, you have an x value, and you have 0 as an output value. That's why. So when we go to solve equations like this that are set equal to 0, we're solving for x-intercepts. We're setting them equal to 0. We're knowing the output value. So here, factors of 12, 1 and 12, 2 and 6, 3 and 4. What factors give me -1? Okay, that's going to be x squared minus 4x plus 3x minus 12. I'm going to factor this by grouping. Take out x. I'm left with x minus 4. I want x minus 4 in the second set of parentheses. So I take out, this is plus by the way, so I take out a 3, a positive 3. So my factors are x minus 3 and x minus 4, x plus 3 and x minus 4. Now, what is x equal? Well, remember, I have to set each factor equal to 0 and solve. So equal to 0, equal to 0. I add 4, I subtract 3, so minus 3 or positive 4. That's solving. This is just factoring, that's solving. And the last thing we did down here was 1 of 7 and 8. So there's part A for you.